Jai Hind to everyone. So, in the lecture series of artificial intelligence, we are today starting our new topic, that is the first order logic in artificial intelligence. So, what is first order logic? As the name declares, first order. That means logic is what? Logic is declaring something to the machine. We know why we are the humans, we are having the interaction between the humans through the communication, but we very well know about that the machine is not able to understand our human language. So for that part, what we want is that to understand the machine, we have to give certain logics or certain rules or certain facts by which the machine can having the understanding for that. That means the logic, you can say it is a set of the rules, the set of the process, the set of the methods through which the machine can having the proper understanding of that. So previously we have discussed about the propositional logic also, and we have seen that propositional logic is basically used for the representation of the statements. That means, for example, this is a cat, that is a dog, or we are in Ajay Kumar Garg Engineering College. That means these all are the simple statements which is showing the representation of the propositional logic. So, but the problem with the propositional logic is that we can only have the information. For example, this is a cat. The machine can only reply us that it's a true or a false. It cannot respond us, it cannot revert back to us that what is the further proper answer. For example, if I am asking to you, this is a cat, you can reply, yes ma'am, it's a cat. Only that statement is been given by to you. But the machine, if I ask to the machine, the database will become the outcome as a true or false, 1 or 0 form. So that's a very big drawback for the propositional logic. So for that part, to enhance the propositional logic content, we have to move on to the first order logic. So it says that propositional logic is not sufficient to represent the complex sentences or natural language statements. So the propositional logic is having the limiting expressing power. As I had already told you that the humans having a proper interaction, same thing what we want from the machine also. The machining having the proper interaction with us. Fine. So for example, we can have a discussion of an example. It says that consider the following sentence which we cannot represent using propositional logic. Some humans are intelligent, or we can say Sachin likes cricket. So if I talk about some humans are intelligent, the machine can only respond in true and false statement, or Sachin like cricket, it only respond as your true or false statements, isn't it? So it says that to represent the above statements, PL logic is not sufficient. We required certain powerful logic, which is called your first order logic. So we'll see what is that first order logic. So the first order logic is the another way of knowledge representation. What is knowledge? We have already discussed about in previous classes. Simply saying the knowledge is the meaningful information is called a knowledge. Of course, the knowledge is the meaningful information which we are acquiring from certain data sets or from certain various places we are acquiring. That is basically your knowledge. So the way of knowledge representation in the AI, it is definitely an extension of a propositional logic. The base is always your propositional logic. That means the statements, the English statements, they all are the facts, isn't it? So definitely that is the base. Never forget about that thing that propositional logic is nothing. Before FOL, you should understand what is propositional logic. Then we have to move on to the first order logic. So FOL is sufficiently expressive to represent the natural language statements in a concise way. Yes, of course, we cannot say that definitely if I'll speak a paragraph on artificial intelligence or start speaking about the paragraph on first order logic, same thing cannot be done by the machine itself. It should have what we want, what I want to deliver to the machine is it should take the limited statements from that. It cannot declare me as it is what I want. You're getting my point? See, the whole theory, the whole we can say a paragraph form or an essay form description, if you are giving any problem statement, I'm talking, take any problem statement. For example, we're working on a project of we want to design a robot, and I started explaining about that to the robot. I want a robot which is having the software, these kind of software should be present, it should work like that it should have the sensors. Whenever I'll start clapping in front of that robot, definitely that robot started speaking. Or if I'm not clapping or I'm having some other noise, the robot should not have any noise, or it should not make any noise, isn't it? So the description I'm giving in my sentences. So if this description I want to give to the machine, is it will the same way I'm representing the statements? No, these statements I cannot give accurately to that machine. So for that part, so these facts, these statements, I have to give it in a proper way, the way of representation. only sentences. We have to convert those sentences in a format, in a logic, in a proper way through which the machine can understand. And of course, after understanding, it should store in that, by which in future, if I want that same response, I can get thoroughly from that machine. Okay, getting my point. So it says that FOL is sufficiently expressive to represent the natural language statements, of course, in a concise way. Concise way means in a smaller way. Of course, the representation, we are having certain rules and regulation. The rules we are representing, the FOL we are representing, but it should not be in a longer way. It should be always try to have a concise way, a smaller way. The smaller way, of course, the storage will be less, the understanding of the machine will be less, the response time will be less, isn't it? So definitely the advantages of that is we can have the frequently response from the machine. Fine. So FOL is also known as predicate logic or the first order predicate logic. What it is a powerful language that develops information about the objects in a more easy way and can also express the relationship between those objects. Fine. So objects, there are certain objects or certain, we can say the quantities. These quantities are having certain relationship, and these relationship has to maintain by representing into a FOL. Clear? So the first order logic, like a natural language, does not only assume the world contains facts like propositional logic, but also assumes the following things in the world. We have to break that statement into certain things. The first thing is your objects. Object can be anything. As mentioned, there are a number of examples are there. A, B, the people, the number, the colors, wars, theories, squares, pits, wampus, everything, it is your object. We are representing that everything, every small, we can say a particle, it is all they are the objects. Now these objects, we are having certain relationship which we have to represent in the relations. It's mentioned the relation can be a unary relation. That means, for example, the red, the round is adjacent, or we can say any relationship. We can have unary, you can have binary, you can have tertiary, you can have n unary relationship. Relationship can be in any type, n number of type. Fine. So that means it's saying representing the example for n relationship, that is the sister of, the brother of, has color, come between, and many more. So we have to maintain the relationship between the objects for the representation of that. Then coming on to the function, what is functionality between that relationship? What function it can perform? What relation? We have declared the objects, we have declared the relation, but what functionality they both are having? That also we have to declare. For example, the father of, the best friend, the third inning of, the end of. Fine. So these should be have the clear identification by which you can develop the first order logic. Again saying, you are treating a machine, you are dealing with the machine having no feelings. Whatever input you are giving to the machine, you will get the output as per your input what you are giving. You're getting my point? You want to get you're putting the 1 inside a machine, you will get the 1 from the machine. So similarly, the first order logic, whatever logic you are putting in the machine, that clearly you will get output from the machine. So you should be clear enough about that thing. You're getting on. So these 3 points are very much important, of course. What are the objects, what is the relationship, and what are the functions. Okay. So a natural language first order logic have basically the 2 main parts. You already know about that thing, that is the syntax and the semantics. Syntax is the statement A plus B equals to C. So that is a syntax. Semantics is how we are declaring A plus B equals to C. So there are certain basic elements in that also, of course. We are having a tabular representation for that. There are a number of constant available. That is the first element is the constant of the first order logic. You should have the clarity of all these points when we will proceed furthermore about how the FOL will works. The constant is, there are a number of constants, for example, the 1, the 2, the capital A, the John, the Mumbai, the cat, and etc. Now coming on to the variables can be X, Y, Z, A or B. Predicates, for example, the brother, the father, and many more relationships. Functions, any kind of function we can have, for example, the square root, the left leg of, and many more. Connectives are, you know, the connectives we have already read about in the discrete also about that thing. That means the and, the or operation, the negation, the implies, they all are in the connective option. Then the equality, the double equality, of course. Then the quantifiers, very much important is the quantifier, that is for all and for some. Atomic sentences. What is atomic sentences? As the name declares, atomic means single. It's a standalone, or we can say it's a singly representation of the statement. Atomic sentences are the most basic sentence of the first order logic. These sentences are formed from a predicate symbol followed by the parenthesis with a sequence of terms. You can have more clarity with the example given below. It says that first we will see how what the syntax is, how we are representing that predicate. We can represent the atomic sentence as predicate, the bracket starting the term 1, comma term 2 till term n. That is the representation how we are representing the predicate value. That is the atomic sentence values. For example, Ravi and Ajay are brothers. It's a simple statement, but now I want to get the machine understand about that thing. That means we can write that predicate like that, brothers. In brackets we can mention Ravi, comma Ajay. Similarly, Chinky is a cat. We are having the relationship also, we are having the object also. For the representation to understanding of the machine, we can write simply as cat. In brackets we will mention the name of the cat, that is your Chinky. So these are the basic atomic sentences, and it is showing how we are representing to understand the machine. Fine. Now coming on to the complex sentences also, that was the basic sentences, the atomic sentences. Now coming on to the complex sentence, they are made by the combining of atomic sentences which are using the connectives. Connectives की help से हम जब combine करेंगे atomic sentences को, then we can have the complex sentence formation, and it is having also a two parts, that is the subject and the predicate. What is subject? Subject is the main part of the statement, of course, and a predicate is, it can be defined as a relationship which will bind the two atoms together in a statement. That means it's a relationship. Predicate is representing the relationship, and subject is of course the main part, the about which we are trying to define. That is your subject. Fine. So here it is representing the pictorial representation of a subject and a predicate. Consider a statement x is an integer. So it is also having the two parts, that is it consists of two parts. For example, the first part, x is a subject of the statement. x is the subject, क्योंकि हम x की बात कर रहे हैं, तो definitely x क्या है आपका, वो subject हो जाएगा. And second part is your integer. So it is clearly defined your predicate part. Clear everyone? So I hope from this you can have the clear identification of what is subject and what is predicate, and now you can easily write about those statements, that how we have to define those statements, how we have to define the complex statements, or we have to define the atomic sentence in the way we are giving to the machine. Quantifiers in the first order logic, we know about the quantifiers. It's a very important topic about the quantifiers. There are a number of questions coming for the quantifiers, of course. So a quantifier is a language element which generates quantification, and quantification specifies the quantity of specimen in the universe of discourse. Quantifiers means the quantifiers we are declaring in terms of the two parts, that is the universal and your existential quantifier. क्वांटिफायर यानी कि एवरीथिंग, जो भी कुछ आपका इसके अंदर कलेक्टिवली फॉर्मेशन में आ रहा है, दैट इज इन द क्वांटिफायर वर्ल्ड, बट वी हैव टू आइडेंटिफाई इट इज फॉर ऑल और इट इज फॉर द सम. सो इट्स मेंशन्ड हियर, these are the symbols that permit to determine or identify the range and scope of the variable in the logical expressions, which is declared by the two parts, universal quantifier and your existential quantifiers. If you're talking about a universal quantifier, that means that we are saying it is for all or for everyone or for everything. That is a simple representation. Universal means सबके लिए, for everyone. It is available for every. We are talking about for all. Fine. Existential quantifier, that means for some or at least one. एक तो होना ही चाहिए minimum. If we are using the existential quantifier. Clear? So universal quantifier, more in detailing about that thing, it is a symbol of logical representation which specifies that the statements within its range is true for everything or every instance of a particular thing. So it is represented by a symbol. We are not simply writing the universal quantifier as a whole sentence. We are simply representing with the symbol which is your V. This is the symbol for that. Sorry. This is a symbol for that, V, which resembles an inverted A. हम A को अगर उल्टा करके लिखते हैं, that means we are saying it's a universal quantifier. मैं किसी भी statement के आगे अगर मैं symbol को लगा देती हूँ, that means उस वो जो statement की हम बात करें, it is for all, for everything, for everyone. जैसे ही आपका ये symbol लग जाएगा, ठीक है बेटा. So in universal quantifier we are simply using the implication symbol. हम किसी भी चीज की बात कर रहे हैं और अगर हम उसको किसी रिलेशनशिप से जोड़ना है या कुछ हमें आउटकम डिक्लेयर करना है, we will always use this implication. That is your arrow outward movement. Fine. So it's mentioned here, if x is a variable, then the symbol of the universal quantifier x is read as for all x. We can read like that. That means this for all x. We can simply call this as for all x, or for each x, or for every x. Remember that whenever you will see this symbol, you have to always speak like that. Okay, the machine will understand all these concepts, but here is whenever you are speaking in terms of the logics, or in terms of the propositional logic, that at that time you have to speak in terms of these terms, for all x, for each x, and for every x. For example, all man drink coffee. ठीक है, यानी कि हम सारे मैन्स की बात कर रहे हैं, हम सब पीपल की बात कर रहे हैं, तो यानी कि हम मान लिखेंगे ऑल, दैट मीन्स फॉर ऑल. इफ हम रिप्रेजेंटेशन की हम बात करते हैं तो वी विल यूज दिस सिंबल. ओके बेटा, सो इट्स मेंशन्ड इन दैट डायग्राम इट रिप्रेजेंटेशन फॉर ऑल एक्स मेन एक्स ड्रिंक एक्स कॉफी, यानी कि जितने भी मेन थे वो सारे के सारे क्या ड्रिंक कर रहे हैं, वो कॉफी को ड्रिंक कर रहे हैं. एंड वी कैन सिंपली कॉल इट दैट, इट विल बी रीड एज देयर आर ऑल एक्स where x is a man who drink coffee. ठीक है बेटा, तो ये जो आपके x है, they are number of x present, क्योंकि सारे हम men की बात कर रहे हैं. It can be number of men. That means this is a universe of discourse. x1 x2 till xn, क्योंकि हमने सारे all men की हमने बात करी है. So we are representing in the universe of discourse, and definitely the combination of all the men, that means x1, x2, x2 till xn, it is having the combination of all the universe of discourse, which is representing in the formation of this statement. हम अलग अलग mention नहीं कर रहे हैं. We are simply combining all these single statements into a one statement, which is representing for all men x. Implication implies drink x comma coffee. And what is x here? Here x is your men. Remember that. Now x is a quantity which we are representing. Man x implies drink x comma coffee. Getting my point? So you should, these basic statements you should understand, by which if you face the complex statements, at that time you can easily express those statements in terms of these quantifiers. Fine. Now coming on to the next one, that is your existential quantifier. So it says that they are the type of the quantifiers which express that the statement within its scope is true for at least one instance for something. जो हमने पहले रीड किया था वो हमने किया था फॉर ऑल, सबके लिए. और एग्जिस्टेंशियल किसके लिए? एटलीस्ट फॉर सम, और एक तो होना ही चाहिए जब भी हम इस सिंबल को यूज करेंगे. और इस सिंबल को रिप्रेजेंट कैसे करेंगे? वी आर रिप्रेजेंटिंग दिस सिंबल सिंपली एज एन ऑपोजिट ऑफ ई. ठीक है, which resembles the inverted e. Fine. When it is used with the predicate variable, then it is called as an existential quantifier. ठीक है बेटा. And remember that it's an important point mentioning here is that we will always use the and or the conjunction symbol whenever we will have the existential quantifiers. हमने universal quantifier में implication को use किया था. Existential quantifier में we are using the and symbol or the conjunction symbol. Okay, clear to everyone? So there is one more example for the same thing. If x is a variable, then existential quantifier will be for some x or for some x, and it will be read as there exists x for some x for at least one x. ठीक है बेटा, यानी कि मैं फिर वही कह रही हूँ, जहां पर भी कहीं भी आपको ये सिंबल दिखाई देगा, आपको सिंपल इसको रीड आउट करना है इन द फॉर्म ऑफ लाइक दैट. There exists a x for some x for at least one x. Okay. So representation for that is the same thing. We are having the universe of discourse. We are having certain boys representing here x1, x2, x3, x4, x5 till xn. Now there are some intelligent boys present in that. ठीक है. So it's mentioning where boys x. That means and the conjunction point intelligent x. कुछ, लेकिन हमने यहाँ के सिंबल क्या लगाया है? ऑपोजिट ई. दैट इज योर एक्जिस्टेंशियल क्वांटिफायर विच इज रिप्रेजेंटिंग कुछ के लिए, फॉर सम, नॉट ऑल बॉयज वी आर टॉकिंग. सम बॉयज आर इंटेलिजेंट, दैट मीन्स. सो इट्स मेंशन्ड हियर देयर आर सम एक्स where X is a boy who is intelligent, यानी कि सारे बॉयज की हम बात नहीं कर रहे हैं। अगर मैं इसकी जगह जो अपना एग्जिस्टेंशियल क्वांटिफायर लगाया, इसकी जगह अगर मैं उल्टा ए लगा देती, दैट इज योर यूनिवर्सल क्वांटिफायर, दैट मीन्स हम सारे बॉयज की बात कर रहे होते। और यहाँ पर मेरा ये जो कंजंक्शन वाला एंड है, इसकी जगह हम यूज करते हैं इम्प्लीकेशन वाला सिंबल, विच विल सिंपली रिप्रेजेंट दैट कि हम सारे बॉयज की बात कर रहे हैं, ऑल द बॉयज आर इंटेलिजेंट। बट here is an example giving the existential quantifier, which is simply representing that कि कुछ boys आपके, for some boys we are talking, there are some boys, there are some X where X is a boy who is intelligent. Clear to everyone? Fine. So points to remember, we have discussed about this point. The main connective for universal quantifier, that is the opposite of A, is implication. We have to have the connection in the relationship in terms of the implication point. And for the existential quantifier, we will always use this and symbol. So there are certain properties for that. अगर हम universal quantifier की बात करते हैं, universal quantifier में if we are representing for all X, for all Y, इसको अगर मैं इस तरीके से लिखती हूँ, for all Y, for all X, ये दोनों ही आपके similar हैं. There is nothing different about that thing. Fine. For all X, for all Y, or we can write similarly to the for all Y, for all X. They both are the same thing. Remember these properties. Don't get confused about कि ये कुछ difference है. No, they are both are same thing. Similarly, in the existential quantifiers, for some X, for all X, it is similar to the for some Y and for some X. Okay, but there is a difference between the representation. For some X, for all Y, it is not at all similar to for all Y, for some X. क्योंकि हमारे जो आइडेंटिटी है, जो हमारे में कहूँ, जो हम सब्जेक्ट ऑब्जेक्ट की बात कर रहे हैं, आपका ऑब्जेक्ट डिफरेंट हो गया। गेटिंग माय पॉइंट? पहले हमारे स्टेटमेंट में क्या मेंशन था? फॉर सम X एंड फॉर ऑल Y, ठीक है। और यहाँ पर हमने क्या करा? हमने क्या करा? फॉर ऑल Y, फॉर सम X, ठीक है। ये जो कॉम्बिनेशन हम लेके चल रहे हैं, ये कॉम्बिनेशन आपका डिफरेंस कहलाएगा, ठीक है बेटा। डोंट गेट कंफ्यूज अबाउट कि ये जो आपका सिमिलर है, ये आपका ये भी सिमिलर हो जाएगा, ठीक है। सो विल सी सर्टेन एग्जांपल्स फॉर दैट। फर्स्ट एग्जांपल इज ऑल बर्ड्स फ्लाई। अगर मैं इसको सिंपली रिप्रेजेंट करूं, वी कैन सिंपली हैविंग द रिप्रेजेंटेशन इन टर्म्स ऑफ द FOL, दैट इज वी आर रिप्रेजेंटिंग फ्लाई बर्ड। ऑल बर्ड्स फ्लाई, fly bird, it's a simple representation. But हम यहाँ all birds की बात कर रहे हैं, it's mentioned here, and since there are all the birds who fly, so it will be represented as follows. For all X, bird X implies fly X. मैं फिर वही रूल को दोबारा से आपको याद दिला रही हूँ, क्योंकि हम सारी birds की बात कर रहे हैं. We're talking about for all, for everyone, for all the birds we're talking. So we are using this symbol, that is your opposite A, that is your universal quantifier. Sorry, and we are using the symbol, the implication symbol for that. Okay beta. Now next statement is your every man respect his parent, ठीक है। अब इस क्वेश्चन में हम देखते हैं, we are seeing इसमें जो predicate है वो आपका क्या है? वो है आपका respect, and we are having the two values X and Y, क्योंकि हम man की बात कर रहे हैं, हम parent की बात कर रहे हैं, हमारे पास दो ऑब्जेक्ट्स आपके आ गए हैं। So we are having two objects in that part, X and Y. तो हम रिस्पेक्ट में हम लिखेंगे x, y, जिसमें x क्या है आपका? x आपका मैन हो जाएगा और y आपका पेरेंट हो जाएगा, ठीक है बेटा। सो इट्स मेंशन्ड हियर, सिंस देयर इज एवरी मैन, सो वी विल यूज फॉर ऑल, दैट मीन्स वी विल यूज अ यूनिवर्सल क्वांटिफायर, एंड वी कैन सिंपली रिप्रेजेंट इन टर्म्स ऑफ फॉर ऑल x, मैन x, which is having the implication point respects x, parent. Okay, fine, clear. I hope with these basic examples you can have the easily understanding how to write the statements using the quantifiers. Fine. So we'll see for more examples. Moving on to some certain complex examples for that. But some boys play cricket. So in this question, of course, हम बात करें, हमारे पास यहाँ पर दो चीजें आ रही हैं आपकी। एक आ रही है आपके बॉयज की बात करें, एक हम बात करें क्रिकेट की। क्रिकेट यानी कि आपका हम we're talking about a simple game, ठीक है। Some boys plays cricket, तो यानी कि plays में आपके पास दो टर्म्स आ जाएगी, play x, y। आपका x क्या है? वो आपके boys हैं, और y क्या है? हम एक गेम की बात कर रहे हैं, ठीक है बेटा। So since there are some boys and we will use, हम कुछ की बात कर रहे हैं, हम यहाँ पे यूनिवर्सल क्वांटिफायर नहीं यूज करेंगे, हम सम की बात कर रहे हैं, हम लिमिटेड कुछ bunch of बॉयज की बात कर रहे हैं, तो इसीलिए हम यहाँ पर यूज करेंगे दैट इज योर existential quantifier. Okay beta, so we can represent in terms of for some x boys x implies plays x comma cricket. क्योंकि हम क्रिकेट की बात कर रहे हैं इसलिए हमने यहाँ पर implication का सिंबल यूज करा है. डोंट गेट कंफ्यूज अबाउट दैट पार्ट. जब हमने वहां पर यूनिवर्सल क्वांटिफायर यूज किया था, मैंने आपसे कहा था कि यूनिवर्सल क्वांटिफायर के साथ हम लोग इम्प्लीकेशन यूज करते हैं, एग्जिस्टेंशियल के साथ हम एंड यूज करते हैं, लेकिन हम तब यूज करते हैं हम दो जब एंटिटीज को हम साथ में कंबाइन करके यूज कर रहे हैं. ठीक है, यहाँ हम बात कर रहे हैं वी टॉकिंग अबाउट अ सिंगली गेम. इन दैट गेम वी आर टॉकिंग ओनली अबाउट द क्रिकेट, तो दैट इज व्हाई वी आर यूजिंग हियर एज एन इम्प्लीकेशन सिंबल. ठीक है, नाउ विल सी द फोर्थ एग्जांपल. दैट मींस नॉट ऑल स्टूडेंट्स लाइक बोथ मैथमेटिक्स एंड योर साइंस. इसमें भी आपकी दो चीजें आ जाती हैं, एक है आपका स्टूडेंट और एक है आपका द सब्जेक्ट, दैट मींस योर मैथमेटिक्स एंड योर साइंस. so we in terms of x and y we are declaring the domain of that object. जैसे हमने बात करी वो क्रिकेट था, तो हमने डोमेन की बात करी गेम की. यहाँ मैथमेटिक्स और साइंस है, यहाँ हम बात कर रहे हैं आपके सब्जेक्ट के बारे में. ठीक है बेटा, सो सिंस देयर आर नॉट ऑल द स्टूडेंट्स, सो वी विल यूज फॉर ऑल विद नेगेशन द फॉलोइंग रिप्रेजेंटेशन फॉर दिस. क्योंकि हम सबके सारे स्टूडेंट्स का यहाँ इसमें मेंशन है नॉट ऑल स्टूडेंट्स. ऑल भी मेंशन है, नॉट भी मेंशन है, तो हम ऑल के लिए हम क्या यूज करेंगे यूनिवर्सल क्वांटिफायर. नॉट के लिए हम क्या यूज करेंगे सिंपली वी विल यूज द नेगेशन ऑफ दैट. So negation for all x, student x implies that it likes x mathematics and likes x comma science. देखो मैंने कहा था ना बेटा, implication हम क्या यूज कर रहे हैं for representing the outcome, for representing the output. But yes, जब हमने बात करी है कि हमें दो चीजों के बीच में कंबाइन करना है, at that time we are using the and point. ठीक है बेटा, clear to everyone? One more example we are discussing. Only one student failed in mathematics. In this question the predicate is failed x comma y. x क्या है यहाँ पे आपका स्टूडेंट है, y क्या है आपका सब्जेक्ट है, यानी कि मैथमेटिक्स की बात करें दो चीजें आपके इसके अंदर आ गई हैं. so there is only one student who failed in mathematics, so we can have the simple representation for this. हम कुछ की बात कर रहे हैं, at least one की बात कर रहे हैं. so for some x, student x failed x comma mathematics, यानी कि हम बात कर रहे हैं क्योंकि हमने बात करी है मैथमेटिक्स क्योंकि हर कोई पढ़ रहा है, एवरीवन इज having focusing on the subject. so that means अगर हम y की बात करते हैं, y हमने यहाँ मेंशन करा था, y is your subject वो सबके लिए है. so for all y it is simply representing that x is equivalent to the y and student of y negation failed, क्योंकि आपका एक ही बच्चा फेल हुआ है, एटलीस्ट वन स्टूडेंट आपका फेल हुआ है x कॉमा मैथमेटिक्स. ठीक है बेटा, यानी कि स्टार्टिंग में हमने बताया कि आपका एक स्टूडेंट फेल हो रहा है लेकिन वो सब्जेक्ट आपके सारे के सारे स्टूडेंट्स पढ़ रहे हैं. तो फॉर दैट पार्ट इट इज इक्वल टू दैट द स्टूडेंट y implication negation of failed x comma mathematics. Clear to everyone? I hope you will easily get understanding from these examples. So the next topic, a small topic, we are discussing again about the free and bound variable. What is free variable? A variable is said to be a free variable in a formula if it occurs outside the scope of the quantifier. जो भी आपका scope है, जो भी आपका डोमेन है, अगर उसके हम बाहर की हम बात करना शुरू कर देते हैं तब उसको हम कहेंगे आपका फ्री वेरिएबल. उसका हम यूज ही नहीं कर रहे हैं. तो ऐसे वेरिएबल अगर मुझे आइडेंटिफाई करने हैं अपने डोमेन के अंदर, अपने प्रेडिकेट लॉजिक के अंदर, या जो भी मैंने टर्मिनोलॉजीज पर यूज कर मुझे आइडेंटिफाई करना है, जो मेरे कहीं यूज नहीं मैंने उसको करा है, दैट इज योर फ्री वेरिएबल. ठीक है बेटा, तो फॉर एग्जाम्पल विल सी एन एग्जाम्पल फॉर दैट. For all x, for some y, p x y comma z, where z is a free variable. क्योंकि हमने यहाँ पर x और y को रिप्रेजेंट करा है, हमारा x यहाँ पर यूज हो रहा है, हमारा y यहाँ पर यूज हो रहा है. For all x, for some y, इन दोनों का यूसेज हम कर रहे हैं, बट z का यूसेज यहाँ पर कहीं पर नहीं हो रहा है. बट इन अवर डोमेन वी आर हैविंग द डिक्लेरेशन फॉर दैट इज x y and z. तो z को हम मान के चलेंगे कि z आपका एक फ्री वेरिएबल है, उसका कोई यूज नहीं है. दैट मीन इट्स इन फ्री वेरिएबल, उसको हम कहीं और भी यूज कर सकते हैं. ठीक है बेटा. सेकेंड वन इज द बाउंड वेरिएबल. इट सेज दैट अ वेरिएबल इज सेड टू बी अ बाउंड वेरिएबल इन अ फॉर्मूला इफ इट अकर्स विद इन द स्कोप ऑफ द क्वांटिफायर. अगर आपके स्कोप के अंदर आता है, अगर आपके डोमेन के अंदर आता है, तो डेफिनेटली उसको हम कहेंगे आपका बाउंड वेरिएबल. फॉर एग्जाम्पल, फॉर ऑल x, a of x, b of y, here x and y are the bound variable. क्योंकि हमने x और y दोनों को यूज करा गया है. दोनों ही आपके यूज हो रहे हैं यहाँ पर, तो हम क्या कहेंगे, आपका x और y क्या है वो आपके बाउंड वेरिएबल्स में काउंटेबल हो जाएंगे। थैंक यू।